Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning, and you're very welcome to another Signpost webinar. Today we'll be discussing climate adaptation and tillage with our changing weather and patterns causing issues on many tillage farms in Ireland. Should farmers continue to do the same thing and hope for a better result, or can we adapt to the management to reduce the impact on our tillage farms? And we're delighted to be joined here by Ciaran Collins, Teagasc Crops Specialist, to discuss the issues and opportunities to meet the challenge ahead. Ciaran, good morning.
Morning, Cathal.
And we're also joined by Méabh here, who's going to help us out with the questions later on. Méabh, good morning to you.
Morning, Cathal. How are things?
Good. I suppose, Ciaran, before we get into your presentation, maybe you tell us a little bit about the kind of work that you're doing here in Teagasc.
So yeah, I work, Cathal, for those that wouldn't know me, I work as a crop specialist. So I suppose really it's a link, I suppose, like all the specialists really, between the research and advisory, so we work quite closely with both, and I suppose knowledge transfer really is our key role really. Whether that's through with discussion groups or seminars or one-to-ones and that, so that's the role really.
And lots of challenges ahead, and I'm sure you're getting lots of questions and issues to kind of come up solutions with, so hopefully you'll have plenty of that for us today.
Yeah. It's been a challenging year, I suppose, really, and it's apt, I suppose, we're talking about climate change because I suppose weather always has had an impact on crops, but I suppose we are seeing some extremes in the last 2 years, I suppose, really,
Yeah. So Ciaran, there, if you want to maybe get your slides ready.
So thanks very much, Carl, for the introduction, and look, for the next 25 odd minutes there, I'm going to look at climate adaptation in tillage. And I suppose, as we spoke about in the intro there, like weather always has a big influence on all farming activities and tillage especially, particularly around, I suppose, the key times really of sowing and harvesting in terms of getting work done. But I suppose climate change does bring, further challenges, and, we're all aware of the impacts of climate change. So what I'm going to do during the course of the presentation is maybe just briefly look at maybe some of the data from Méabh and what we're seeing. And then I suppose look a little bit deeper into the challenges that brings for tillage farmers in Ireland. And then some of the adaptation measures that either are in progress or that farmers are looking at, and some of the remediation, if you call it that, maybe as well. So I suppose, look, just to start off maybe in a kind of a more of a global context, I suppose, really. This is a well-worn slide from it here, and that I've borrowed. So, like, Ireland's climate is 0.7 degrees warmer and 7% wetter when compared to the average period of 91 to 2020, when that's compared to 1961 to 1990. So that those two 30-year blocks. So we are wetter and we are becoming warmer, and that obviously does have impacts. And I suppose really we're, from a crop growing perspective, it does result in extended growing season, which can be a positive. But I suppose then the challenges that we're facing is rainfall is increasing in likelihood and intensity. And, we're seeing that through some of the storms that we've had in recent years. And then I suppose the prediction is for more prolonged heat waves leading to droughts and higher extreme temperatures. And I suppose the other one as well that's important for us is fewer cold extremes. So, we're tend to get milder winters, and that has an implication in relation to pests and diseases as well. So I'm going to use, I suppose, the last full calendar year maybe just as an example of what's happening, and then some of the implications that does have for tillage farmers. So 23, aptly enough, it was Ireland's warmest and wettest year on record. So I suppose it is a good place to start in terms of, looking at some of the implications of climate change. So February, I think, just a few stats on it. It was the 5th mildest and the 6th driest recorded. And then March 23 was the wettest March on record. And March is the key month for sowing spring cereals. So then in May was May 23 was the second warmest on recorded, and June 23 was the warmest June on record. Average temperatures above 16 degrees for the first time. And then I suppose, getting into harvest, you can see July there was the wettest on record. And into August we had Storm Betty, and then September was the third warmest September. And then October was really wet. And again, going back to March, crucial month for sowing of spring cereals. October is the crucial month for sowing winter cereals. And as I said in the intro, I'm in Middleton here, and we had Storm Babette there on the 18th of October. There was 100 mil of rain fell in 36 hours. So, there were guys out planting on the Monday and Tuesday. Storm Babette fell on the Wednesday, and there was a lot of damage done, and crops had to be resown as a result. So again, I suppose, look, that's just some of the implications of climate change. And then to finish it off, November was wet as well, and we did certainly have tough conditions there as well. So look, that's 23. It was probably an extreme year, but I think it probably does highlight some of the implications of climate change. So what I'm going to do in the next few slides now is just look at the impact on crop production. So just before I go there, you can see that picture on the screen there that was taken in down your part of the world, Cathal, in Wexford. But you can see that's just the impact of flooding. You can see where the water ran across the middle of the field there. So you had very good establishment on the top of the field, as you can see, and you can see where water ran across the field. There's practically no plants in part of the field there, and that's not going to yield very well. And it's very difficult to repair that when it's in patches like that. So that's a big cost to the system. So just maybe more kind of globally first in terms of the impact of climate change and crop production. I've just identified 5 kind of key ones here. I'm sure there are many more, but like we do have increasing CO2 concentration. So, I suppose high CO2 levels kind of a compensatory effect on growth, especially for C3 crops like wheat and barley that we grow here in Ireland, or grass for that matter. But sometimes that's offset then by heat and drought, but it can be a positive. In contrast, high CO2 levels, it only benefits C4 plants like maize under drought stress. And then secondly, weather extremes, that's obviously a big consequence of, or a big impact of climate change, and that I've kind of discussed in the previous slide, whether that's drought, high temperatures, or rainfall and storms. I think another kind of significant, maybe over time, impact of climate change is shifts in suitability of different crops. And we might look at that a little bit later on in the presentation, kind of a more northerly expansion, I suppose, of warm season crops. So, maybe like grain maize, even soybean meal, sunflower, maybe grown in more northerly. So that's something that could be an impact of climate change. I suppose one that we're seeing already is certainly the occurrence of new weeds, pests, and diseases. Again, I think milder winters are a key factor in our climate, and we'll have a look at some of those again in the minute. And then there's the environmental impact. So when we get storms like Storm Babette that I mentioned earlier on, you're getting washing of soil, degradation of soil, soil erosion, nitrate leaching, phosphate losses. So, that is an impact in when we get those kind of storm situations. So maybe to dig a little bit deeper, maybe just into the impacts of wetter weather. Look, the first obvious one is soil workability and reduced machinery work rates. And, like we saw in 23, when you get, wet months of April, key planting month, and a wet month of October, which we've had, this year hasn't been too bad, but, October 22 and 23 have been quite difficult. You get soils are very difficult to work. Farmers can't plant crops in a timely fashion when they need to plant them. And the consequence of that as well, that machinery is the highest cost on tillage farms in Ireland, and we tend to be over capacity as a consequence of having to try to do, a lot of work in very short windows. And the same for harvesting. combines in Ireland are much, much bigger than, as a percentage of area harvested compared to other countries simply because of the amount of grain that has to be harvested in a short period of time. Um, so I've kind of covered, I suppose, the impact of planting and harvesting. And I suppose the other impact of wetter weather on harvesting is that those delays often lead to quality, deterioration and, from wetter weather. And, we're looking at the likes of higher infestation, pressure of some native diseases like fusarium. And talking to Stephen Kildea, our cereal pathologist lately, Stephen would say that we're seeing an evolution or an evolving of fusarium species, and that's a consequence of wetter or warmer weather. And then, as I discussed there as well, impacts of wetter weather in terms of nutrient losses through nitrate leaching and phosphate runoff. So just maybe for those that wouldn't be overly familiar with tillage crops, the picture on the right would have been taken about this time of year last year. 300 plants per square meter. That's a field of winter barley, and that's target. That's what the farmer would have planned there, would have sown that field in good conditions, would have got good weather afterwards, and that's the target and the aim. Whereas the field on the left was taken last year as well, in November, and that's the field would have been planted in the same conditions as the field on the right, but that's the consequence of heavy rain post planting. Just saturated soils. The seed was just sitting in water for too long, didn't germinate, and you can see the consequence there. So that field would have to be replanted in the spring, and obviously there's a huge cost to that, in sowing it twice, and the cost of seed the second time over as well. So just to drill a little bit into October rainfall, because I suppose, look, we are just at the time of year that we're in, really, it's a crucial month for sowing winter cereals. So what I've done here, and it's just a small bit of explanation, is I've taken the data from the 4 weather stations that cover the tillage areas in Ireland. So I've taken Cork Airport for the south, Johnstown Castle in Wexford, Oak Park in Carlow, and Dunsany Grange up in Meath to sort of cover that northeast area. So when you look at the rainfall over a 15-year period, you can see that there is a linear increase there just in that short period of time. Now, heavily influenced obviously by 22 and 23. So, that's just showing, I suppose, we are getting more intense rainfall at a crucial time of year. And then if we just narrow that into a 10-year period, a 9-year period there, you can just see what farmers have had to deal with in the last 10 years. You're seeing a sharp increase there in rainfall in those 4 weather stations, just to, as I say, narrow it into the tillage area. Now, you did have dry seasons there, looking particularly in autumn 16 and 18 there as well. But look, we are seeing wetter autumns. This year, thankfully, has been a little bit better, and there's a good area of winter cereals sown. So I suppose this is just a small bit of explanation as well. The red line or black line, depending on the color of your screen there, that is the line here from this graph. That's just showing the October rainfall, and the bars are the winter cereal area sown in that year. So if we take this harvest gone out, harvest 24, you can see that 35% of the cereal area was sown to winter cereals. So obviously the remainder was spring cereals. And you can see the rainfall in the previous October, which would be October 23 up here where I'm pointing my arrow there. So high rainfall obviously means lower area of winter cereals. But if we go back to harvest 2019, just as an example, we had a dry autumn, a dry October of 18, and that led to an increase in winter cereal area. And the winter cereal area for harvest 19 was 60% of the total cereal area compared to 35% in the harvest just gone out. So I suppose the message that I'm trying to give in that slide there is farmers do respond to drier autumns by increasing winter cereal area. So it just shows the impact that weather has on the winter cereal area. And when we do our costs and returns, the winter crops generally are more profitable, certainly from a feed basis, whether that's feed, barley, wheat, or oats. So that's some of the impacts of wetter weather. Just to look a little bit closer then at the impacts of warmer weather. So obviously summer droughts are going to be a key one there, particularly the dry months and mightn't necessarily be drought conditions, but dry conditions in May and June do impact crop yield. So I suppose beans really would be the one that would be least tolerant to dry weather, and there's been a big effort in recent years to increase, native protein sources, and beans are really, really suited to our climate, cool, plenty moisture, temperate climate. But beans are very, very sensitive to dry periods. And when we get dry periods for spring sown beans in May and June, it impacts flowering. We tend to get pod abortion in very dry conditions. So that's an impact of summer droughts. Spring barley would also can be adversely affected, particularly just, recently sown crops, hitting a dry spell. They don't get to tiller and develop, and we end up with thin crops, which is a big impact on yield on spring barley. And then at the other side, maybe winter crops, because they're more developed, they will be affected by summer droughts, but maybe not as severely as beans, say, for example. And then another impact of warmer weather are nutrient imbalances. So what I mean there is nitrogen applied versus crop yield. So to take a spring barley example, a farmer might sow a crop of spring barley in March in very good conditions and would fertilize that crop then to target yield. So for argument's sake, a farmer might put out 150 kilos of nitrogen. Target or expected yield might be, say, 7.5 tons per hectare. But when we get dry conditions post-fertilizer application, we tend to get poor crops, and yield might be reduced. And if I use 2018 as an example, a lot of crops would have been now in that year they're actually sown later, but fertilized maybe for 7.5 tons and maybe only yielded 5. So you've got a nutrient imbalance there, and then you have obviously that nitrogen is hanging around in the soil. And when we get, wet weather in the autumn, that's a risk to be lost through nitrate leaching. And then I suppose, look, lower crop yields, economically, obviously, is reducing profitability. And the other two impacts that I kind of highlighted there from warmer weather, is the higher occurrence of pests and diseases. So there's a picture there on the right of stem rust. That picture was taken by Stephen Kildea in winter wheat plots in 2020. And the last time that we had seen stem rust in Ireland was 1963. So again, that's more an impact of warmer temperatures, particularly actually over the autumn and the winter period. And then, as I said at the start, a big implication in relation to insects. And I suppose one of those, again, one of the impacts of milder weather in the autumn or the winter, that we're getting more generations, we're getting a greater number of reproductive cycles. And aphids is probably the classic example there. So what I might do, I might just use aphids as an example of maybe the consequences, and then maybe just in relation to some of the research work that's going on in terms of adaptation there. So aphids are they're a vector of barley-yellow dwarf virus. So barley-yellow dwarf virus, for people that wouldn't be involved in the crop scene, it's a virus that affects all cereals, but it affects barley more so than wheat and oats. But it can have a serious impact in yield. Yield losses of up to 80% are possible. Normally wouldn't be that high, but it does depend on severity. But it is a major. It is a major, aphids are a major pest, and virus is a major consequence of that. So aphids are the vector. So we have many different species of aphids, and then we have different virus strains that affect crops as well. And global warming certainly does favor the development of aphid populations due to their short generation time and large reproductive capacity. And an example I have on the screen there, if temperature increased by only 2 degrees it would allow 5 extra generations of aphids per year. So if you think of aphids migrating into a crop, say from into a cereal crop from, say, grassland, they'll go in and they'll feed. But when we get milder weather over the winter period, that gives them time to reproduce, produce extra generations, and this secondary infection then that causes the damage. Virus rate replicate. It moves through the plant, but that increases with temperature to a certain optimum, and then it decreases after that. But milder weather, as I say, is the big issue there. And I suppose as global temperatures continue to rise, plant viruses in general, they will be more difficult to control. So just to give, there's just 2 projects, excuse me, just to highlight there. Department Agri Adapt funded project there is improving models for major vectors of BYDV, excuse me, in current and future climate scenarios. So what they're looking at there is to predict the optimum timing of insecticide, and then to predict aphid virus pressure in relation to changing climate. So I suppose really it's to look at adaptation, really measures that we can take to, I suppose, predict aphid pressure. And farmers, they don't want to prophylactically apply insecticides. So when you have good forecasting tools and prediction tools, that reduces that load there. And there's another SFI Elevate project, and some of the objectives there are establishing an explanatory model of how dominant BYDV strains in Ireland impact barley yield using controlled inoculation field trials. And again, it's establishing the impact of a changing climate on cereal virus transmission, and then the insect vector behaviors there as well, and establishing BYDV phenotyping platform to evaluate new and old genetics. So I suppose really what the model looks like, and I think it's a really good one and it's well developed, is that we've got forecasting tools. So we've got suction towers, and I've got a picture in a later slide, which measures aphid migration. So once we can measure aphid migration, we can predict that aphids are moving, and there's a likelihood that there are aphids in a crop. But then we need to identify the species, because not all aphids are transmitting. Not all aphids, number one, are carrying viruses, and then different aphid species carry different viruses that can different impacts on crops. So we need to identify the aphid species. And then thirdly, we need to identify the different strains that they're carrying. And I suppose are they carrying virus or not? And secondly, then what virus strains are they carrying? Because some viruses can be very detrimental to yield and other viruses less so. So I suppose building all those forecasting tools in, that gives farmers then, in time, we'll be able to tell farmers, well, if you planted on a certain sowing date, the risk of virus is high, medium or low, and the farmers then can make an informed decision as to whether or not that they need to apply an insecticide. And I suppose a further development there, which is really positive, is breeding. And I'll talk about breeding a little bit more in a minute, but breeders now are breeding varieties that have tolerance to barley or dwarf virus. So the aphids will feed on the plant. The plant will still get the symptoms of virus, but the plant has an inbuilt tolerance to withstand the virus. So the yield penalty in that scenario is much lower than it would be in a variety that didn't have that tolerance. So that's just a little story on BYDV. Just to move on to weed research, again, as I said earlier, climate change does have an impact on weeds and the different species that we're finding. So in terms of the research that's happening, we're looking at weed distribution maps and species lists just to generate climate and production specific knowledge. And then I suppose a big part of that is in around the area of herbicide resistance and the underlying mechanisms causing that. And herbicide resistance is a really, really big issue. Getting products registered now is very, very difficult. So we're seeing a very, limited number of new products coming on the market. while an awful lot of the older products are going off the market with no replacements. And the issue there is that there tends to be an overuse then of the same herbicide types or herbicide from the same groups. And the implication of that is herbicide resistance. So that's something that's really important to monitor and keep an eye on. And then there's the whole grass weed management around in non-inversion crop establishment systems. And we're just finished a really, really good project, an ECT, Enable Conservation Tillage project. And that looked at the implications of grass weeds in non-inversion systems. So that's non-plough-based systems, and how best to manage those both culturally and through herbicide management there as well. And there is, just on the machinery side, there is more of an emphasis now on non-inversion techniques, and some of that's around climate change, but also, to get work done, trying to increase capacity of machinery there as well. And then there's the whole, a little bit like the BYDV scenario, trying to get away from the pesticides there, so looking at cultural or non-chemical integrated control methods. So that's a big focus of research there at the moment. And that's kind of all underpinned by surveys linking weed challenges and farm management practices there as well. So maybe just a practical example here. You can see a weed there, that's Italian ryegrass there on the top. And you can see wheat there in the lower picture. But just to give you an idea, there's 50 Italian ryegrass plants there per square meter versus 280, which would be a target for wheat. But when you have that population of Italian ryegrass in a crop, that has a serious implication on yield. And you're talking about producing, what's that, over 116,000 seeds per square meter there in Italian ryegrass. You're talking about producing, what's that, 8,500 grains of wheat there. So, the competitive nature of weeds like Italian ryegrass, it impacts significantly on yield. And then there's a whole herbicide resistance piece around Italian ryegrass, which is very, very difficult to control in cereals. So moving on to crop diseases. I spoke earlier on about weed stem rust. It was recorded for the first time in decades, I think since 1963, when it was found there in 2020. And stem rust in the 50s was associated with barberry. That was the host. But, in 2020, I don't think there was any barberry in the hedgerows in close proximity to where that stem rust was found. So the likelihood is that was an influx of wind-borne spores, from further afield. And, that stem rust, brown rust and yellow rust are common enough diseases, but we are seeing more of them in Ireland now than we did, say even a decade ago, particularly brown rust in barley. Yellow rust in wheat was often confined to the northeast of the country. Where I am in Cork now, we see a lot more yellow rust now. And there might be an interaction there with varieties as well, but it is a symptom of a changing climate. And then fusarium species that I spoke about earlier on, we are seeing, evolution there in the species that we're finding. And that has huge impacts in deterioration in grain quality. If you think of, say barley for brewing or distilling, that can lead to rejections there, or food grade oats and stuff like that. So, they're all implications of the likes of fusarium there. So it's moving on really to, I suppose, the nub of today's presentation then around adaptation and what can we do. I've kind of highlighted the main challenges, not all, but what can we do, or what can farmers do to adapt, I suppose, really to a changing climate. And I suppose really around the weather one, really, in terms of sowing and harvesting, I think optimizing the crop mix is something that's within all our controls. So we tend to, if I'm in an area that's suitable for sowing, say, spring barley, or if I'm in an area more suitable to winter wheat, there tends to be an over-reliance on one crop. And that's, from an economic perspective, that does make sense. But I suppose really in terms of mitigating risk now, we are talking about, optimizing crop mix. So if I can take a because of the time of year we're in. If I'm a farmer that plants mainly, say, winter wheat and winter barley, I have a 3-4 week window in October. But if I expand my crop mix to maybe including rye, now rye can be sown from, say, the 15th of September, or if I introduce, say, winter oats into my rotation, which you can push out into November, I've sort of gone from a 3-4 week window to a 6-7 week window. So I've widened my, my sowing base there. And then I suppose, I've given myself a better chance in terms of getting the crops into the ground, but also then I spread my harvest risk as well with, with a range of harvest dates from, say, the middle of July out to maybe early September. So I suppose that's just an example of optimizing crop mix and what that can do. And also introducing break crops and more break crops, the likes of beans, the likes of oilseed rape, financially, over the duration of the rotation, they add more to the bottom line. And then I suppose as well in terms of adaptation, what we're seeing, I spoke about beans earlier on and how they're very suitable to our climate, but peas are also very suitable to our climate, but they have an issue with lodging, and there's some work going on there. And I have an example in the next slide. Maybe that's something over time that we will be able to do a little bit better. And then, as I spoke about earlier on, maybe longer term, we may be able to grow, the likes of soy or sunflower, whether they'll be practical in Ireland, maybe through breeding over time, but that's certainly longer term. I think a really important one in terms of adaptation is cover crops for a range of reasons. And I know cover crops have been spoken about widely in this forum before in terms of reducing nitrate leaching, but they also have a massive role in terms of soil protection, where we've seen the impact of flooding in some of the earlier slides there, and, where you've got cover crops in the ground, how they can protect the soil. And then I suppose really, as I spoke about with barley yellow dwarf virus, but it applies to all pests, the need for forecasting and disease monitoring and prediction. They're tools that are in development, and they will be really important going forward. So this is just an example of intercropping and some of the research that's going on. So one of the key issues, or the Achilles heel really, of peas in Ireland is lodging. Our climate is well suited to them. We can sow them later than in the spring than beans, and we can harvest them earlier, which is really good, but they tend to fall over and lodge. And some of the research that's going on through Oak Park and led by Sheila Alves there at the moment is intercropping. So it's basically growing a crop of peas, but growing beans in that crop as an intercrop, and basically using the bean as a scaffold, so that it keeps the peas will grow and hang on to the bean, for all intents and purposes, and it helps to reduce the impact of lodging. So that's just an example. There's a picture of a cover crop that I just spoke about there, really, really important. And then, I've spoken about crop rotation. Again, just that broader spread of crops, it really does help in terms of mitigating or spreading the risk. And this is a picture of a suction tower. So that's 12.2 meters high. And that's used to measure aphid migration. So that's a crop of winter barley there. There's a suction tower. A suction tower is basically an upside down hoover. So that's the flight the height that aphids fly at, and it captures them. They're recorded daily then, and farmers kind of an idea then that, okay, aphids are flying or they're migrating or not. And then once we know that they're there, we need to identify the daily samples, what species of aphids are there, because that has implications. And then further on from that, are they carrying virus or not? And then if they are, what strains, and are they damaging? And that's a really important and a really good example of monitoring and forecasting there. So just one or two others I think that's really important in terms of adaptation are improving soil resilience to extreme weather events. And I think improving soil organic matter content is huge there in terms of, enhancing water retention to cope with droughts and nutrient availability. And it just makes soils more resilient overall. Conservation tillage and no-till farming has a role here. as does cover cropping that I've spoken about earlier on, but also the importation of organic manures onto tillage farms to help to use organic manures, both to raise organic matter and to increase fertility overall. So I'm nearly at the end there, Cathal, but just it's not all negative. There possibly are some opportunities down the road as well. The extended growing season does give possibilities for yield increases, and that can be a positive. I've spoken already about the possibility of new crops and varieties, and that may result through genetic improvement and breeding, but also the shift in production patterns. Maybe crops that are not sown in Ireland, in time may be suitable for Ireland. And just finally, our needs in terms of tillage. I think overall, really resilient cropping systems is really the key to it. It's that spread of crops, spreading your risk. I think that is really the number one for me anyway. I think integrated pest management is obviously huge in terms of monitoring, early warning systems, that we don't prophylactically apply pesticides, that we have, warning systems and monitoring systems in place. Crop breeding has a massive role to play. I mean, we can't understate the impact of that. I've given the example, just one of many, in terms of BYDV tolerance there with some of the winter barley varieties we have at the moment. And there are many more in terms of disease and pests as well. Crop insurance is something we've never had in Ireland. It would be common in the US. But again, as we see, I think, more extreme weather events, maybe that's something that will come into play. And I suppose all of this is underpinned by policy, agricultural policy and strategies to mitigate climate change and climate adaptation measures. So just finally, before I leave there, Cathal, just acknowledge the input there of Louise McNamara, VJ, and Stephen there and the help in the presentation there today. So thank you.
Ciaran, excellent. That was a really good presentation. Certainly opened my eyes up to a lot of the challenges and certainly some of the opportunities we have there as well. I'd just like to remind everybody, just before we get into it, that there's a Q&A section there. So stick your questions in there and we'll get Ciaran will answer them along the way. But Ciaran, I suppose the first thing that kind of the whole way through your presentation, the one thing that was kind of coming into my mind all the time was there's a good few challenges there, and I know we don't want to be too pessimistic, but there will be a financial burden, and I suppose how are farmers feeling about that? Is there enough money there from at the moment, or is there enough supports, or not even just now, but 10 and 20 years time when we do have these kind of changes coming at us?
Yeah, it's a really good question, and I suppose there's we could do a whole presentation on it, I suppose, if you like, but we are commodity grains to start there, say feed and the tillage industry in Ireland, I suppose, maybe to go back another step, is so important in terms of native feed, and I've shown the example of, what the potential of, say, proteins like beans and peas there. So, that native grain thing is so important. But, commodity grains like feed barley, feed wheat, that is sort of the low end of the scale, really. And I suppose really our focus is on those sort of higher value products. I suppose that's the first thing. But to back really to your question, I mean, climate change, unfortunately, is increasing costs in terms of, just to take the machinery example, farmers in Ireland are way over capacity compared to, for the acreage worked and the size of the machinery that they have compared to, say, our EU counterparts. Not a mind to go to different continents. And that's just an implication of the amount of work that is to be done in short weather windows. If you talk to any grain merchant, the whole harvest could come in 10 days if it fell that way, and but that does come with a cost, and it's, one of them. I suppose the other one is, we are capable in Ireland of getting the highest yields in the world because of our climate, but that does come with a cost. We do have higher pest and disease pressure, and I suppose some of the tools that we have are, the tools that we have to control these pests and diseases are reducing. Our toolbox is reducing because of, products going off the market and the flow of new products coming on isn't as strong as it used to be. So again, it's trying to adapt around that, trying to find, I suppose, like I said, the forecasting tools, all of those things that try and help farmers to make decisions, I suppose, really.
And I suppose when you mention it, we talk about you mentioned like there was stem rust and aphids and a lot of stuff where traditionally we would hit them with a spray, a pesticide or an insecticide or whatever it may be. And I know we have to reduce our herbicides and our pesticides and our insecticides. That's going to be a big behavioral change, isn't it? Because integrated pest management is trickier. It's much easier just to fill the tank and go out and spray. It's going to be a challenge.
It certainly is. Yeah, it certainly is. I often, integrated pest management, you look at it like as if it was a pyramid. So the pesticide is a little triangle up on top, and all the culture and control methods are along the bottom. So you have your cultural control, you've got your forecasting, your basically non-pesticide measures, I suppose, if you like. And I suppose you go through all of those steps of the chain, and then the end is the pesticide, and that bit is still really important. But you have to exhaust all the other measures first. I'd have to say when I started in this industry, the triangle was very much upside down. You had there was a wide range of pesticides available, and that was the first port to call. Whereas now, I think there is, and as you say, there is a behavioural change there now. Where we are looking at variety tolerances, all of those things, and then you exhaust all of those measures, and then you rely on the pesticide. Because again, you can't just keep applying pesticides for various reasons. And even I gave the example of grass weed control there. If we keep reapplying the same pesticides, we're just going to end up with none. Resistance will build up over time.
Yeah. Maeve, lots of good questions coming in.
Yeah, the questions are starting to fly in for you here now, Ciaran. So, look, I suppose just something that jumped out at me even during your presentation was how much there seems to be a similarity between your climate adaptation measures, your climate mitigation measures, and even then your measures that will help protect water quality, and how kind of the three things nearly seem to be they seem to be really linking in together, even more so in a tillage scenario than it would maybe in a grassland system. So I suppose like maybe there is a huge potential there to try and address more than one issue at the one time, even when you're talking about cover crops and stuff like that. It's just something that really jumped out at me.
Yeah.
I suppose just kind of leading on from that, then, like there is a question there in terms of how climate change will have a net negative result on water quality from a tillage perspective, thinking about that increase in rainfall and stuff like that. So I suppose the question is, what can farmers do to reduce this? And then what extra department regulations could likely be the outcome of the lower water quality from a tillage perspective?
Yeah, I suppose there's a good bit in that. I suppose, firstly, tillage tends to be on the lighter soils, more free draining soils. So no matter what enterprise you have on lighter soils, nitrate leaching, to use that example, will be more likely. I suppose that's definitely the first thing. I think the big change that we've seen in since the last nitrates directive is that now we are required to have green cover over the winter, whether that's through a sown crop, whether that's through a cover crop, or whether that's through stubble cultivation that creates that green cover. So, there is a requirement now, and I suppose that's really what you're asking in terms of there is a requirement now to have that green cover over winter. And I think that obviously will positively affect water quality. I think that's the big measure there that's going to make the biggest change, really.
Yeah, absolutely. And again, I questions there coming in terms of the targets that are there for the Irish agricultural sector in terms of reducing emissions. There is targets there to increase the amount of tillage production in Ireland. And how do you see that being possible going forward, I suppose, when there is so many significant challenges there for the sector at the minute?
Well, I think that's the real big positive of tillage in Ireland. The contribution that it can make to climate change is a really big one. We had a study with Tirlawn there recently, and just to use one crop as an example, winter oats, a lot of farmers in Ireland are actually growing carbon neutral winter oats, when particularly when the straw is chopped and incorporated back into the soil. So I think that's a real feather in our cap, and it's something that I don't think personally is rewarded enough. But anyway, but to grow carbon neutral crops in Ireland is very possible. Lots of farmers are doing it already.
Yeah, so yeah, huge opportunity, like that feeds into maybe the opportunities that are there as well. But it just comes back to maybe having that bit of flexibility within the systems that we're introducing. And then just another question there as well, you were talking about these heavy rainfall events and coming back to maybe the issues around water quality and stuff like that. But how do you foresee these adaptation measures then helping with the likes of going from a period of extended drought where you have hard soils, and then you have a heavy rainfall event then leading to that increased risk of runoff? And when you get those two weather events following on from each other, it tends to obviously exacerbate the effects of both of them.
Yeah, I suppose I used 2018 as an example, I suppose, and that was an extreme one where we obviously did have, we did have a severe summer drought. But then where cover crops were sown in the autumn of 2018, there was phenomenal growth in them, I suppose, for two reasons. One is they were sown early because the harvest was finished early. And I suppose if I could make just one point on cover crops, sowing date is so, so crucial. Sowing cover crops in the middle of September is not really a runner, even though sometimes we're forced to do it maybe in a season like this. But, sowing them as soon as possible after the harvest, you're getting larger biomass, you're getting greater capacity then to absorb that nitrate that's available in the soil and holding it in the soil, which is obviously the crucial bit. So cover crops, getting them sown early, I think that's really the crucial piece of that one there.
Yeah, and it's great to see the likes of the cover crop measures and that are being incentivized through the likes of the acres scheme and stuff. So I suppose, there is some financial support there available for farmers in some of the measures.
There is, and the water EIP is a real positive one there as well. Where there's financial aid there for farmers to get them sown. And as I said, it's just really to get them sown early really is the big part of that one.
Yeah, absolutely. Have you a couple of questions there, Cathal, I think, as well?
Yeah, I just, Ciaran, one thing that jumps out and a few questions that come up here, and it kind of hit me during your presentation. We're always looking for silver bullets, right? So what is there any kind of technologies or automation kind of coming down the road at farmers that would help them? Because there's a kind of another question in there to mix it up as well, that we're always looking for something to make our life easier with technology. I've even seen digger drivers over in Canada sitting in an office operating these massive diggers. But and the other side of that is with the technologies, we might need less labor, because labor is a major issue as well on farms.
Yeah, technology is a double-edged sword. Like, I mean, the cost of new technologies is huge. So maybe just leave that one aside for a minute. But to look at the positive of technology, I mean, something, and you mentioned earlier on supports, like I think TAMS has been brilliant in terms of, increasing the amount of precision technology on tillage farms, like a lot of the new sprayers, for argument's sake, they're using automatic shut-offs, so it takes driver error out of it in terms of on and off, reducing the amount of overlaps in fields. We're seeing GPS RTK technology for sowing crops, precision down to 2 centimeters, so reducing overlaps, underlaps. We're seeing it particularly in relation to fertilizer spreaders. And I think tillage farmers, to be fair, have led the way in using that technology, so, getting the right amount, even distribution of fertilizer across. So that level of technology, which is supported by TAMS, is a real positive. As I said, it does come with a cost, maybe over time, and the likes of TAMS does, in fairness, mitigate some of that. And I suppose to be maybe a small bit more futuristic, I suppose I did mention quite a bit about, machinery getting larger, heavier, and the impact then obviously that can have on soil. As you mentioned there, autonomous, tractors and vehicles may be futuristic, but, they are being used now. So maybe tractors in time maybe will be smaller or lighter, and the driver might be, as you said, like you or me sitting looking at a laptop. I don't know, but that's I think that possibly is the longer term future of it, really. Yeah.
Yeah, because you'd see kind of stuff online where there's drones going around now that are actually able to sow first even, and like will all that kind of technologies kind of mitigate against the wetter climate that's coming, or the warmer and wetter climate maybe?
Yeah, I suppose the likes of drone technology, and I suppose again it's developing. I know we touched on it a little bit in the ECT project, identifying weeds, where you can identify a specific weed in a crop and maybe target spraying then instead of obviously spraying the whole field, that you're just targeting the sprays to the parts of the field that it's needed. And the same with disease, I suppose, linking in with forecasting tools, and using maybe drone technology down the road where you can identify, an area or a part of a field, to halt the spread of a disease before it gets across the whole field, maybe.
Yeah, I'm just seeing a couple of questions as well coming in with, a few just in terms of adaptation, maybe alternative technologies in terms of introduction of aphid predators. Would that be an option, or would there be negative consequences associated with it? And also then how would you foresee the use of GMO being used in European tillage? So a few kind of more maybe novel technologies in that form.
Yeah, predators is certainly a huge one, particularly in controlled environments. I think it works really well. Biocontrol in field scale scenarios, it's a little bit more difficult, and I know Louise and her team have looked at it and are looking at it. Where you have uncultivated margins on the sides of fields to promote, predators and that. If you think of an aphid, so a ladybird would be a predator. So if I can, in some way increase the amount of ladybirds in my field, well, can that act as a predator and then as a tool as well? I suppose I know that one of the complications in it is that there tends to be a lag period where the pest has to build up, and then before the predator will be there, and then the damage can be done in the middle. But it is being investigated there as well. The second part, what was the second part there, Maeve, again?
Sorry, the second
yes.
part then was just around the use of
GM.
GMO in Europe.
Yeah. So again, I suppose there's gene editing now is being developed. So we don't have GM in the EU, obviously, but gene editing is certainly a tool that has massive scope and will be very positive for growing crops over time. Like having a variety and probably drought, maybe tolerance, some of those traits would be the first that would be looked at. But having drought or varieties with better tolerances to disease will have a huge implication, especially in a country like Ireland.
Yeah, and I suppose it's already played a massive role, I suppose, over the last number of years. So it'll be interesting to see where it develops going forward.
Yeah.
And then just an interesting question there as well around the difference between maybe the tillage sector here in Ireland and how it differs versus on the mainland Europe. And is there a risk there that EU policy being developed in the future might not necessarily reflect or match up with the system that we have here in Ireland?
Yeah, it's a great question. And I personally, I think that is a real issue. You're dealing with totally different climatic conditions in anywhere in Ireland where crops are growing compared to, say, the south of France. As I said earlier on, we are capable of getting the highest yields in the world because we're not water restricted, whereas other parts of the world are. But the consequence of that is higher levels of pests and diseases. And, to remove something that controls, a disease in Ireland, across the whole EU, it may not have an implication in a lot of countries, but it may have, a disproportionate implication in Ireland, and I think that's one of the, for me anyway, downside of just the broad brush EU policy, I think.
Yeah, it's important to
I
have
think
it
you've
specific.
loads of examples, but there are, pests and diseases that we find very difficult to control because products have gone off the market that wouldn't have much consequences in other countries, but do in Ireland.
Ciaran,
Yeah,
so just if you're talking about at a bigger level, I suppose, outside Ireland, and you mentioned about protein crops, are we kind of too set in our ways in the type of crops we're sowing in Ireland, or is there room for improvement as regards those those crops, those protein crops, where we know the protein is going to be an issue into the future, and there's probably a gap there.
There is, and like it is, in fairness, it's a big focus of EU policy and national policy, and that's fed down into the research, that's going on in Oak Park, investigating, different sources of protein. It captures a lot of research projects that are going on at the moment. As I said, currently faba beans are probably the crop that's most suitable for Ireland, and I suppose a lot of the more recent research has gone on in that area. Peas have been grown in Ireland for years as well, with the Achilles heel of lodging, and that's being addressed. But as you say, going forward, there is more potential. And I suppose you asked a question earlier on about supports, and like the protein payment has been a real incentive there. Before the protein payment came in, and just shows the impact of policy. Prior to 2015, I think the area of beans in Ireland was somewhere around 2,500 hectares. The season gone by with 17,500 hectares. But the protein payment has been the big factor there. And what a payment like that does, it takes the risk out of it for the grower, because they know if they grow the crop, I'm going to get the payment anyway. And then, you work with the crop, and you get your best yield that you possibly can. But you do have that security. And I think incentives like that, that's where policy has a big impact. And as you say, we're deficient in protein in across the whole EU, not mind Ireland. So, any developments there are welcome, really.
I think we have time there for one more, Méabh, if you have it.
Yeah, well, I suppose just to maybe shine a light again on the importance of the tillage sector within Ireland and on a global scale, I suppose, is just especially in light of the war in Ukraine and stuff like that. Maybe just a comment on the importance of food security from a tillage point of view, and maybe increase in our level of self-sufficiency within that as well. I suppose it kind of comes off of the protein part as well. It's all feeding into
It sure
each
does.
other.
Like we just with the nature of our land and the amount of grassland we have in Ireland, we'll never be self-sufficient in cereal grains or protein in Ireland. Is that imbalance will never be rectified. But I think obviously we can help ourselves by increasing the tillage area. I know that the Department of Agriculture had a stated aim to increase the tillage area to up to 400,000 hectares. Now that unfortunately in the last 2 years has gone in the wrong direction. But you're so right. Like it is so important, and I think going back to a point I made earlier on, we can get very high yields, but commodity grains, feed barleys, feed wheats that are traded on a worldwide basis, it's really difficult to compete in that space. And I think really, aside from obviously producing native feed, but I think those value-added products like the food grade oats, even the proteins, we're really, really good at growing, malting barley for the brewing and distilling industries. I think really that's probably our focus and our target. And feed grains will be there as well. As I said, we'll never be self-sufficient in Ireland. That's just the nature of the landscape. But, I think from a tillage perspective, the focus will always be on those higher value grains, really.
Yep, look, unfortunately, I think we're after coming to our time now, so we'll have to pull the plug on it there. But just like to thank everybody for sending in their questions. There are some really excellent questions, and Ciaran, really like to thank you. You're a fountain of knowledge, and we're after learning a lot from you here this morning. And there's so much more to talk about. But thanks a million for a presentation today. It was excellent. Méabh, thanks a million on the questions. Excellent as always. And I'd like to thank Yvonne there in the background. She's pulling the strings there, keeping the show on the road for us. So, look, next week, don't forget to tune into us again. We'll be around at 9:30 again next Friday morning. And next week, we're going to have Laurie Ray Van Lauren. She's a Walsh scholar in Teagasc, and she's going to be talking about improving water quality, the role of local actors and ecological factors in mission-orientated agricultural innovation systems. It's going to be another excellent presentation as well. So make sure you tune in again next week, Friday at 9:30. So with that, wish you the very best and chat to you again soon.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.